I want to briefly go over how an experiment is set up in the normal conducting of an experiment. Here we have an example, representation of a sample where each little colored line there is intended to be a subject in this population that we have. And from this large population of squiggly lines, we want to draw a sample that is characteristic of the type of people or the type of squiggly strings that we want to be able to generalize the findings of the study to. So we want to establish this population of interest. Doesn't necessarily have to be everyone, but the ones we're interested in. So this is our population. From that population, we want to get a sample. A smaller group of individuals that we can study more reasonably, and we can't do the whole population. And there are a lot of different ways that we can get a sample. Most often in health professions, we are limited to having volunteers, since people have the opportunity of withdrawing from a study. We can't force people to be in a study. So we have a sample that we derive in one fashion or another. To the extent that that sample is representative of the population that we want to speak to, then we say that is a representative sample, and we have what we call external validity. So we're able to generalize our findings back to the population of interest. So the degree to which the study is representative of the sample of the whole population is the degree to which the findings are generalizable back to the whole population. Next, we take that sample of individuals and divide them into, in this case, 3 groups. And for a true experiment, we want to randomly assign them to groups. So we've got 3 different groups. So there are several ways of doing that. Random number generators, or have them pull numbers out of a hat, or flip a coin, however you decide. But the subjects have to be assigned to these groups on some random basis, not as a result of their own preferences or the convenience of the experimenters. And this is an important part of an experimental design because it eliminates bias that might otherwise exist between the groups. The aim here is to have our different groups be as similar as possible to each other at the start of the study, so that we know that if they have a change, or if they are different at the end of the study, that it's likely to be as a result of our intervention and not just some intrinsic difference between the groups. Next, in our design component, we have actually constructed an intervention, and so we'll have some kind of treatment that will give each of the subjects, and this treatment will be different between groups. So all of the subjects in one group will receive the same treatment or intervention, and hence we have the colors, the blue treatment here, the green treatment here, and the purple treatment down here. And one of those may be a control of some sort, meaning that they get a null value or an ineffective treatment to compare the others with. Then once we've had that intervention, at the end, then we collect our data. We want to find out if our intervention had any effect on the outcome measures. And so our data are collected from each individual in each of the samples. And you see we generated some numbers out here. And these are considered the data. So all of our collected measurements are the data that we then do our statistical calculations upon. So what we want to do then is compare these different groups in the outcome measures, that is the data, and see if they are different between our 3 groups. And that's where the inferential statistics come out. We use inferential statistics to tell us if we do have a difference between 2 of the groups, is it a large enough difference to say that it's genuine, that it is likely to be a repeatable kind of a difference, or if it's just likely to be a measurement error. That is, they happen to be different this time, but if you measure the same individuals on another day, they might have slightly different scores, and they really aren't, the 2 groups, or in this case the 3 groups, are really not different from each other. except for just some random variation that exists within each of the groups. And it's important to get that indication of whether the statistic is, or the finding is statistically significant or not, because if it isn't repeatable, or if it's likely to be just a fluke, then it's really not a difference at all. We only have a difference or an association that we can discuss, that we can talk about, if we can say that it's likely to be a repeatable, an actual real finding, that there is a difference. Now this finding of a significant difference between the groups doesn't tell you anything at all about how that difference got there. That's a different process that involves the design of the study and internal validity. But we start with the statistics because you're already familiar with your statistics since you've taken that as a prerequisite course, and we'll get started on the next animation.